The revolutionary discovery concerns Proxima Centauri, the star closest to our Sun. Around it, a rocky planet called Proxima Centauri B, or simply Proxima B, has been identified, which is approximately the size of Earth. What makes this discovery groundbreaking is the planet's position in the so-called habitable zone around its star, which allows for the presence of liquid water. This circumstance hypothetically opens up the possibility of life forms on Proxima B. Finding similar planets closer to us will be extremely difficult, if not impossible. The discovery raises many questions, and here are some of them along with their respective answers. What do we know exactly about Proxima B? To better understand what we know about Proxima B, it is necessary to provide a brief summary of the information gathered so far. A group of astronomers conducted observations using the telescopes of the European Southern Observatory, ESO, and identified a planet orbiting around Proxima Centauri, the closest star to Earth after the Sun, located approximately 4.25 light-years away. Proxima B has an estimated mass of about 1.3 times that of Earth and completes an orbit around its star in just 11.2 days. For comparison, Earth takes 365 days to complete a full revolution around the Sun. It is situated at a distance of approximately 7 million kilometers from its star. While this distance may seem small in astronomical terms, it is important to note that Proxima B orbits a red dwarf star whose brightness is roughly 1,000th that of the Sun. Astronomers have calculated that Proxima B receives only about 2/3 of the amount of light that Earth receives from the Sun. This places the planet in the so-called habitable zone, a range of distances from the star that allows for the presence of liquid water. Based on these estimates, it is hypothesized that the surface temperature of Proxima B is compatible with the presence of liquid water. Are there living beings on Proxima? At the moment, it is not possible to state with certainty. Proxima B shares some Earth-like characteristics, such as mass and temperature, which increases the likelihood of development of life forms similar to ours. However, it also presents substantial differences. For instance, the planet always shows the same face towards its star, much like the Moon does with Earth, resulting in a permanently illuminated side. Life forms could potentially evolve only on the shadow side, where water might be present, and where there would be greater protection from the star's ultraviolet and X-ray radiation emitted in the form of flares. It is important to maintain a cautious approach and not let our imagination run wild. For the planet to support life, it will require an atmosphere dense enough to maintain a moderate temperature, which could range from -33 to over 100 degrees Celsius, as shown in video simulations, as well as some protection from the star's radiation. In any case, if there were life forms on Proxima B, they will likely be more similar to microbes and bacteria rather than little green men. How can we know with greater certainty? Once we are able, if ever, to determine whether Proxima B has an atmosphere and study its chemical composition, we can formulate more concrete hypotheses about the potential presence of life. If we were to detect signs of oxygen and methane, which are elements that degrade rapidly, we could hypothesize that there is some form of living organism regularly refilling the atmosphere with these gases. On the other hand, if we were to find other gases, such as chlorofluorocarbons, it could suggest the existence of intelligent life. Aliens who have polluted their world, similar to what we are doing on Earth. If furthermore we were to discover the presence of ethane, We could even speculate that the aliens have already become extinct. In summary, the primary priority is to determine if Proxima B has an atmosphere, as this would provide a fundamental basis for further hypotheses regarding the possibility of life on the planet. How long will it take to find out? It will take a long time and patience to make new discoveries about Proxima B. If the planet were to transit between its star and Earth, we would have the opportunity to analyze its atmosphere using instruments like the Hubble Space Telescope. We could study the starlight filtered through the planet's atmosphere. However, the chances of observing such a transit are quite low. If, on the other hand, Proxima B does not transit between us and its star, we would have to wait at least 10 years until instruments capable of directly observing a planet so distant and close to its star become available. The James Webb Space Telescope, which will replace Hubble in 2018, is unlikely to achieve this goal. We will have to wait for the completion of the EELT, the European Extremely Large Telescope, currently under construction in Chile. It is expected to be operational by 2024, and with its nearly 40-meter diameter mirror, 39.3 meters to be precise, it could capture light from Proxima B. This could provide us with more detailed information about the planet and its possible atmosphere. However, it will still take some time before suitable instruments are available to conduct further studies on Proxima B. Could it be possible to send a probe instead? A crewed mission on Proxima B is practically impossible with current technologies. Even sending a robotic probe will be a highly challenging endeavor. Proxima Centauri is located at a distance of 4.25 light-years, which is equivalent to about 40,000 trillion kilometers. Even if we were to travel at the speed of light, it would take a little over 4 years to reach there. But currently, this far exceeds our technical capabilities. The fastest probe ever built to date, the New Horizons, took 10 years to travel 5 billion kilometers and reach Pluto. A similar mission to Proxima B would require a staggering 80,000 years to complete. This highlights the vast distance and technological challenge involved in exploring such a distant star system. Is it not possible to go faster? There is already an ongoing project considering this possibility. It is called Breakthrough Starshot, and its ambitious goal is to build and send nanoprobes to the Alpha Centauri system, which includes Proxima Centauri. The probes will be accelerated using a powerful laser and will reach a speed of about 1/5 of the speed of light. This would allow them to reach Proxima B in approximately 20 years. The Breakthrough Starshot project has been funded with $100 million by the Russian investor and philanthropist Yuri Milner, but it is still in its early development stage. The discovery of the exoplanet Proxima B could accelerate the project's timeline and attract new and larger investments to make the mission possible.